I am Jude Felix from the Department of Mechanical Engineering, Moore College of Engineering and Technology. Today we are going to discuss about the deformation and fracture. Basically, this topic comes under the subject Engineering Metallurgy, Materials and Metallurgy in the unit number 5. Basically, what is deformation? Deformation is a change in shape due to an applied force that can be a result of tensile force, compressive, pulling, etc. Basically, the basic concept of deformation is nothing. If you are, for an example, you are going and sitting in a chair. If the chair slightly bent, that is known as deformation. The external force is applied to any object. The object shape or size is slightly changed. That is known as deformation. There are two types of deformation. One is elastic deformation and plastic deformation. The elastic deformation is nothing but this type of deformation is reversible once the forces are no longer applied. For an example, you are sitting in a chair, and when you are getting up from the chair, when you are sitting, the chair slightly bends. When you are standing, when standing from the chair, the load is removed, and the chair comes to the normal position. That is known as elastic deformation. The deformation happens when the load applied. When the load is removed, the deformation comes to the normal size. That is called as elastic deformation. The plastic deformation is nothing but if you are sitting in a chair, the chair bends. After you after you get up, after the load was removed from the chair, also the bent position is not as bent. It will not come to the normal position. That is known as plastic deformation. What is deformation means? When an external force is applied on a body, its size or shape is changed. We call this as deformation. There are two types of deformation. One is elastic deformation and a plastic deformation. If the load is removed from the body, the deformed body comes to the normal shape. It is called as elastic. For an example, you can take as a rubber band also. When you are stretching the rubber band, the load is given. It it is stretched. When you remove the load from the rubber band, it comes to the normal position. That is a nice example for elastic deformation. For the plastic deformation, if you are applied external forces applied on a body, the deformation it will not come to the normal shape after the removal of external force. This is called as deformation. I think you have understood the basics of deformation and types of deformation. The next topic is fracture. Fracture is nothing but a separation of a solid body into two or more parts under the action of stress. The fracture is nothing but basically when we are giving an external force, that material breaks into two or more parts. It is called as deformation. If the material we are giving an external force, if the material bends, we called it as deformation. If the material breaks, we called it as fracture. That is the difference between the deformation and fracture. There are four types of fracture. One is brittle fracture, ductile fracture, fatigue fracture, and creep fracture. First of all, we come to brittle fracture. The brittle fracture is nothing but a rapid propagation of cracks. When a crack occurs, that materials which goes for a failure. For an example, you can take tiles, anything else, ceramics, anything else. If something a load for applied on a ceramic particles, the crack will be initiate rapidly and it will break in a sudden way. In the first of all, you can see the first image. That original shape is round, and the fracture position also get after the breakage of two pieces also we can join it. That is a rapid propagation of cracks. Which all the material which breaks into two pieces and we assemble it also, if it comes to a normal shape, it is called as a brittle fracture. In the another diagram you can see about the stress strain curve. For the brittle fracture we can't draw the stress strain curve because when the material undergo the first impact itself, it will goes for a failure. So we can't go for the stress strain curve. Basically the brittle fracture is for the ductile material, brittle material like tiles which the load applied, it breaks. The rapid propagation of cracks. Next fracture is ductile fracture. The ductile fracture is nothing but if a slow propagation of crack. If a crack comes to a material, the crack will slightly initiate into it, and it goes long and it's break. For an example, you have studied in a strength of material laboratory, the tensile testing machine, UTM. You are giving a pull on the both direction for a steel rod. There is a formation of neck where crack appears, then it takes a time for breaking. For the original shape, or in the first image also you can see, first the original shape is there, then fracture occurs. When we rejoin, we will not get that back the original shape of the material because it elongates. That also you can see in the stress strain curve, ductile fracture, and the stress strain curve also maximum the elastic limit, then it will go for an elastic limit, and finally it breaks the neck formation, and finally it breaks. Brittle fracture is a rapid, in simple way, the brittle fracture we mention it as a rapid propagation of. Brittle fracture is slow propagation of crack. Ductile fracture is slow propagation of cracks. Next fracture is called fatigue fracture. Fatigue fracture is nothing but repeatedly applied load. Basically, this fracture occurs in a lot of. Fatigue means repeatedly applied load. For an example, you're sitting in a chair. Basically, this is an example. You bought a chair. When you are sitting in the chair is on the load. All the time you are not sitting in the chair. When you are sitting, the load is applied on the chair. When we are going, the load is in free of cost. Sudden one day the load when the chair breaks. That fracture we call this as fatigue fracture. Repeatedly applied load. We are not giving the load. We are repeatedly applied. This fracture happens in the majority on the we have all, we are using the vehicle also. It is when you are stopping it as it is an idle position. When you are driving the bike or something else, that running the load happens, something or the working of all the function is happen. When we stop the vehicle, it will be idle. Anything happen that fracture inside something, this is called as fatigue fracture. Fatigue fracture is nothing but repeatedly applied load. The last one is creep fracture. The creep fracture is constantly applied load. Constantly applied load. Constant. For an example, in the ceiling we have hooked the fan. The full load of the fan is on the hook. The hook is holding the fan. Constantly the load of the fan is holding on the hook. One day the hook get failure. That failure is called as creep fracture. This is all about the fracture. Fracture is nothing but the separation. The external load is applied. The material separated into two or more parts is called as fracture. There are 4 types of fracture according to our syllabus: brittle fracture, ductile fracture, fatigue fracture, and creep fracture. The brittle fracture means it is a rapid. Brittle fracture means a rapid propagation of crack. Where if a crack occurs, it breaks. External load, suddenly an impact load is happen, it breaks. That is called as brittle fracture. Ductile fracture means slow propagation of crack. A crack appears, and the crack will propagate slowly inside the material. And the third one is fatigue fracture. Fatigue fracture is nothing but repeatedly applied load. Repeatedly applied load. This fracture only occurs in the majority of the way. When repeatedly applied load. The last is creep fracture. Creep fracture means constantly applied load. That's all the Salam. I am very able think you have learned about the deformation and fracture. I know you have understood the basics of deformation and fracture. Thank you. We will see on the next class.